you do.
Yeah, which makes life so much happier. Okay. There's the people. Okay. You're good.
I can show you how I got to where I am so far. We'll go from there.
Okay.
So step number 1.
Because I kind of want to get this one done pretty quick. I gotta get back to work.
Yeah. So sorry. We can haul through it. It's great.
Okay.
It makes sense once you like watch the videos.
It really
I
does.
promise.
It's pretty, like, even though I have all this crazy stuff written on here, the stuff you really need to remember is this
the
right
equation.
here
Yeah.
and this one right here.
Yeah.
And it's really not that hard. So you're doing all the stuff we've done before, and just add that you have to do the square root of the sample size that they include in there. It's really
Yeah.
easy.
It's really not bad.
It's not hard.
Okay.
Oh, okay. So it's
One
not
of them
just
kind of
like
caught me off guard because they're like, what are the odds of one of the sample sizes
so this is all
being
normal.
greater than this? And so you do the square root of 1, and it's 1. It's like you're doing a normal problem.
Okay.
That makes sense.
That's what got me.
All right.
I just
Okay.
brought numbers.
So,
So 3, have you done 3?
yeah, I
And,
did.
like, I feel like I could draw
Got 0.087.
0.087.
Yeah, you just plug the numbers in, and then you just
See what
and
the
then you
number
just
on the
click
top
on one on each side, and it comes up with the same number.
is. Right.
Okay. And then the next one, I'm not completely sure it's right.
Okay. Which of the following will have a similar standard deviation if 9 observations are randomly drawn from the population?
I put the distribution of the sample.
That's what I feel like it would be too,
Okay.
considering like
Or
what
I
this
guess
lesson was
we could
about.
technically
Right.
come up with our own.
Okay. And then this one, I still get central limit and large law of large numbers.
Yeah.
So,
Which of the following results implies that in a spread X
gotta
increases
practice
as
more
the
on that.
sample size increases?
especially if we're getting close to test time.
Pretty sure that's the central one. But I could be completely wrong. Let me pull it. Let's see. Glory to the
Yeah.
Okay. Okay, central limit theorem. As the sample size n increases and becomes large, the distribution of the mean becomes approximately normal.
Let's talk about the spread.
My bad. Let me go to actually
Normal
do
distribution.
distribution. Okay. Yes. Maybe it could be normal distribution. Decreases as the sample size increases. That would make sense.
Okay.
The normal distribution, right?
Yeah, we'll go
Yeah,
for
we'll
it.
go for it. We'll see how it goes.
Okay, so this one should like normal. You just have to do the normal z-score thing. So I got 0.148.
0.1. Wait. The normal z-score thing.
Yeah,
Just the
so
normal
yeah,
z-score
so
equation.
yeah, you just do x minus the mean divided by the standard deviation, take the split, and then you get your number.
Okay. Corresponding. Cool.
Okay, and then this one.
For 7, the probability is that a randomly selected student will score above 160 on the quantitative portion of the GRE.
This one I
Okay.
probably got wrong because
Okay,
because
so because you have to use the applet situation, right? Or,
what do you
or
mean? Oh, you know what? Hey, why don't you just put? We have the
so underscore of. So for the applet, the above that would just that's just when you highlight this section. Yeah.
The one. Oh, it's
So like this is
1.045.
step 1, or like this is its own reaction, and then do this.
What'd you get?
1.045.
Could be.
Oh,
That's
That's the Z-score though, right?
no, that's the Z. Yeah, that is the Z score. Okay, so wait, what are we looking for?
What is the probability? So the probability is the top part of the tablet.
That's not right then. Okay.
So put the Z-score that we got and left on the bottom.
Then that's the 148 we got from the last answer.
What is the Z-score? Okay, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE rounding? I feel like I understood this during the videos, but now I can't remember.
So yeah, because the oxygen.
How we do
And
that.
earned a score of 160 in the quantitative portion. Z score
So the
is
number 6 one's the Z-score.
Yeah.
oh,
So you did that. That's the issue.
0.
Did you write the probability?
Wait, what'd you get?
The Z-score is on the bottom.
Yeah, I put it on the top. Yeah.
This is the Z-score. It's a 148. Right.
Yep. Right.
Like,
So that's still correct.
Okay.
Right. And
Okay.
then the top would be 44%. It's 0.441.
Okay.
Okay.
3 decimal places, that works.
Okay.
We'll cross our fingers that it's right.
I hope so.
So a random sample of 5 students was selected to take the GRE. Their scores were, what is the Z-score corresponding to the sample mean of the students?
So I added all up.
And then
divided it by
divide by 5.
5.
Yep.
And I got 160.
Okay.
Did 160 minus 158. Man, this is the exact same thing. This is the exact same thing. So it's no.
Wait, it's just the Z-score.
Minus
So
50.8. 9.2. Then 9.2 divided by 8.8 equals 0.045.
zero, 1.045.
Yeah. 0.045.
But we didn't have that answer before. Did we?
Yeah.
Oh, was that 6?
Yeah, that's the point. That's the 0.148.
Oh, 0.1. So I had that right. That's correct.
That's
Okay.
why
Well, there is a sample of 5 students. So what if you do? Since there's a sample on there, so we would probably have to do the square root of
Do the square root
5.
of 5, yeah.
Yeah, so do the 8.8 divided by 5. It's like 2.2, 3, 6. Go that far. So 8.8 divided by 2, 6. 3, 9.
And then you want to divide.
2 divided by 3.
I don't know if that's like
That equals 2.338.
So 2.
2.338. No, that's not the answer.
No.
It's a 0.00. Yeah. Okay. So it just go to 1. So 0.01.
So 0.00.
No, it'd just be 0.001.
Oh, right.
The
3
9 would-
decimal places.
Yeah. No, it's not 0.01. It's just 0.01.
0.01.
Yeah, because the 9 would round up to 1, or the 7 would round the 9 up, and the 9 would round the 0 up. Get it?
Yeah. So 0.01.
Yeah. Hopefully that's right.
We'll find out.
Hopefully
What is
Where did this do?
today.
Is that what you mean?
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Wait, what?
Greater than. No, because greater than is the last third of the normal applet.
Right? So you do have no two.
Greater than or equal to would be.
Yeah. It's the same answer.
Okay.
Oh my goodness.
Wait. Hold on.
And we weren't even talking about the much. We did all these costs. It's water forming.
It's 160. So.
Pretty self-explanatory. Maybe it's like because do you remember that chart she had where it was like this had the
Okay. Hold on.
like,
160.
you know, I don't know if you have like the word for each,
Equals
but that doesn't make
9.2.
sense. That's not
And then 8.9 divided by square root 5 equals 9.2 divided by 6 So the z-score equals 2.3377. That's what the z-score is. Because, so this,
Oh, that's to get the area. The applet is the area.
yeah.
Oh. Wait, was the last question the area? Or were we getting
Number
Z?
9.
Number,
So, okay, so number
So
8
number
was the Z
8
score.
is just the z-score, yeah.
Yeah, so we need
So
to change
that's
that.
2.337.
3. No, you need to round up. So 338.
Okay, 338. Right.
Okay. And with that Z score,
Okay, now you put that into the applet to find out if it's in the greater, so the last portion.
Yeah, because I just put the points from 1 in. I was like,
And that doesn't make sense, yeah.
okay, so it is. So 9 is the 3D printer.
Point 0.01.
All right.
Okay.
Okay, now we're on the same page. To get the area, I need to. Oops. Okay.
Okay.
All right, I might
Suppose.
have to relook some of these answers just to make sure.
Yeah.
And didn't put like the area when we were supposed to
For the z-score.
how do we decide if the sample is large or not?
So,
By the sample size,
okay, so
Yeah.
the first
which I don't know, because I know like in the videos they were like it was a sample size of 50, and that's a large sample.
Yeah,
Size.
that's the
And I
thing.
was
They
like-
don't tell us the rule of what's considered a small
Small
sample.
sample.
Yeah, because for like number 10, it's like asking,
Like,
we know if it's a massive sample size, you know, it won't matter.
okay, suppose the mean of the GPA for BYI students was 3.5. The standard deviation is 0.7. It is well known that the distribution is left skewed. A random sample of 81. Okay, so that's large. Students will be drawn. What is the shape of the sampling distribution? This random variable which represents the sample mean of the 81 students who were selected. Well, if it's left skewed, it's left skewed, right?
Yeah, if it's left skewed, but the thing is, we have a high the sample size is large, so it's
Yeah.
normal.
Right. Oh,
So-
right.
So is it
Right,
normal?
right.
Yeah, it's normal because
If
the
it's
sample
the
size
size
is large.
large, so
Yeah.
approximately normal.
Yeah.
Oh my gosh, seriously.
This is why I hate stats. It's not, I feel like it's not concrete enough.
I know. I feel
Yeah,
that.
it's a-
Like, give me an equation on yourself.
Absolutely, I can do that.
Every day. Okay, what is the mean of the distribution of the sample means or sampling distribution for all possible samples of the size 81 that could be drawn from a parent population? So, what is the mean? That's what we're looking for. What is the information here? Standard deviation
Oh,
is,
the mean
oh,
is-
the mean was 3.5, right?
3.5, yeah.
And so if you had a carbon.
Just making sure we read the problem.
Seriously though.
The standard deviation.
Yeah.
It's
What is the
zero-
standard deviation?
0.7.
Was it 0.7 or 0.5?
So is that
Pretty
of
sure
the
it's
sample means though?
0.7.
Is the 3.5 the sample means?
Yeah,
Yes.
it's 0.7.
Perfect. Because the sample mean and the mean
Yeah.
equal each other.
Okay, what is the probability that the mean of GPA for 81
Will be less than 3.3. How do we do that again? Okay.
0.07?
No.
Well,
0.7. I know what part of the applet to look at to figure that out, but I don't know what to put in. Okay, the probability that the mean for 81. Okay. Standard
Would be less
deviation.
Oh, less than 3.3. So
0.7 divided by square root 81.
So it's okay. So 3.3 minus 3.5 divided by 0.7 divided by the square root of n, which is 80.
We're doing 3.5 minus 3.3.
So that's 9. So 0.7 over 9. So yeah, 3.3, 3.5, which is 0.2.
And then 0.7 divided by the square root of 81. Right?
Yeah, so it's 9. 9 is
Like,
Seriously. So I get 2.57 for the z-score. So if you put that
no, that's only the equation.
applet,
The doll makes sense.
right? 2.5,
You said you got 2, right?
2.57.
2.57. So I got 3. Oh,
Did I do it wrong? I might have done 3. I did 3.5 minus. Okay, I did it
so
backwards.
yeah,
So
3.3
3.3
minus
minus.
3.5
Hold on,
equals
we're gonna-
it's negative 0.2.
Where?
Oh, I did 0.9 instead of 0.7. That's my problem.
Oh,
So it is going to be a negative number. It's just
right. Okay, so I just got the positive side. So, oops. Clear. Oh, fetch. Crap. 3.3. My calculator. Okay, and then 0.7 divided by square root
negative
so it's negative
0.57.
0.257, which I can just put 2.7 in there. And we want what again?
Less than.
Oh.
0.0051.
0.0051.
This one.
So it's just doing 3 decimal spaces.
Yeah. 0.005. We're almost there, guys.
Okay.
Okay,
Greater than 3.3.
so greater than, so then you just it would be the same thing.
Yes.
It's greater than 3.3. So no, you need to click
Everything.
you need to click the middle part too.
No, you don't.
Yes, you do.
No, you don't.
Because we got the negative score, so we need to get that chunk and that chunk. All of that's greater than. So we need that chunk. We need all of that in there.
Because that represents.
That represents that whole score right there.
Okay.
So that's why we need all.
I'm with Michael.
Okay, I'm just because on the videos they only had this third highlighted for greater than, so that's why I'm only hesitant. But we'll find out. But it's the same thing.
What's the answer?
0.9949.
How does that
So
make
point
sense, though?
I know.
Yeah, it
That's
doesn't make sense. Yeah, there's like me and 5 and so.
But that
so I don't know.
well, if you guys
Why would it be so complicated? It doesn't make sense though. Because yeah, you're saying it's still the same answer.
So 3.3 is the normal.
Mhm.
And so it's saying, what is the average? What is the probability you will score difficult for greater than 3.3?
Right.
When the average is 3.5. So,
It should be high. It does seem really high.
Yeah, that's the average. Yeah.
well, we'll find out.
Yeah.
What was it again?
Yeah, that's one.
Did you type it in?
Yeah.
What was
so
it?
it's 0.995. Yeah.
Oh my gosh.
Yeah, but that's just my battery's almost dead. United States Coast Guard assumes the mean weight of a passenger commercial boat is 185 pounds. Previous value was lower, but raised after tragic boat guidance. Standard deviation is 6.7. 6.7. Weight of the random sample is 48. Commercial boat passengers may record. The sample mean was determined. Sample mean is 7.6 pounds. And the probability that a random sample of passengers will have a weight that is X extreme or more extreme, either above or below the
And it
mean
goes back to the electronegativity.
in the observed sample.
Carbon is more
Means that we're not only interested in values that are lower than the ones observed in those values that are far away.
Weight that is extreme or more extreme in the observed sample. No, an extreme or more extreme means that they are not only interested in the values that are lower than the ones that were observed, but also the values that are far away from the mean as here.
Say you had 4 kids. You would want your 4 kids to hang out with you all the time, right? But when your wife has one of the 4 kids, you miss that one, right? But you still have the 3, but you want that one back. So that's kind of how that's Does that make it? Does that make more sense?
So yes, so this would be actual combination.
Because this is only one. But it's only one.
You get negative 1.9 the z-score.
1.92.
Yeah. Huh?
But my question is,
So we want negative
why does
1
why is this one
equals.
that like if they were negative charge here, they're negative charge here, and we would have.
And what are we looking for again?
We're looking for find the probability that a random sample of passengers, weight that's extreme or more extreme than what was observed in the sample.
Which means why exactly? Is that just a-
549?
I don't know.
You need both ends.
Is it both ends? Oh, right. Extreme or more. Okay. So 5. 5.
6.055.
Yes.
So then you have.
Let's see the damage.
And then
Oh, okay.
zero charge.
So we missed one.
Just
2,
one?
Several.
Oh, no.
Missed 12.
12.
Sorry if I made that more confusing
No,
because I was.
now we got it down though.
So number 12 is what we missed? Or we missed 12 out of
12 is wrong.
Okay, so let's look at that. So the standard deviation of the distribution of sample mean sample what for what? What? How's that wrong? How's that wrong? That's the standard deviation, right?
Standard deviation is 0.7.
What is the standard deviation of the distribution of the sample mean sampling distribution for all the possible samples of size? Can we? What? I think they have that scored in wrong. Because it tells us what the standard deviation is. So how can that one be wrong?
So then
Wait, how do you solve for the standard deviation again?
So this is 5.
Okay.
Oh, we probably have, we have to do the sample size. So, sorry, we have to do 0.7 divided by the square root of 81. So,
Oh, to equal the.
yeah,
Oh, right.
and that'll equal the actual standard
So
deviation.
0.7 divided by the square root of, okay, just of 9. So it's what? So 0.078.
Yep. Whoops. Okay, that one's fixed. Good.
Good
Okay,
catch.
which one now?
What's the other one?
Does you want to start at the top or bottom?
Top, yeah.
Okay, 3.
3. Okay. Using the normal applet, find the standard norm. Oh, the combined area for those z-scores. Okay, you want to read me the z-score?
So Z is 1.358.
1.358.
Oh, that's the probability. Oh, okay. Oh, let's get the middle part. That was wonderful.
The applet's super confusing. Okay, hold on. I didn't read my answer. Okay, so it's 0.8255. So 0.826.
Yeah. Okay.
So 0.826. Okay. What was the next one?
5.
Hey, guys, we got 4 right. Good job.
Okay,
Oh,
so it
crap.
was a normal
So-
distribution.
It was not.
No.
So then it must be the central.
Okay.
Because it's not the law of large numbers. That doesn't make sense.
It's not the 68.
And it's not this.
That one.
No. Yeah, that one.
Right. Okay. It was
Well, okay, hold on. The law of large numbers, as the sample size increases, the sample mean draws closer to the population mean.
So the spread decreases. Is that comparable to that?
Is that the central limit or?
That one's the law of large numbers. So if the sample size increases, the sample mean draws closer to the population mean.
No, it just says the
So-
spread increases and the sample size increases.
Okay, so we should be okay with it. We'll find out. We'll have somebody else
Okay,
test it
6.
too. Okay, 6. Okay, Dan earned a score of 160 on quantitative
What's the
portion
answer?
theory. What? How'd you get there?
Show feedback and I clicked it.
What was the answer?
Is that the answer? It has numbers.
Yeah, equals x minus
Hold on.
minus
Dan earned a
mean
score.
divided by the mu equals 160.
Okay, so
1.8. Oh,
160.
see, yeah, that was
So
the
it was
issue.
the-
It was just
so
the
it was
z
the-
score.
and you were
That was-
doing the thing.
Yep.
Hold
so,
on, I
yeah.
wanna do the
Yeah, so
calculation.
that's right. This answer's right.
Hold on, I wanna solve it.
I think I find that or something.
Well, I mean, we're gonna have to do it for the test. Normally I'm like that, but like I don't want to have to retake the class. Okay, hold on. What was the sample size?
What's the next?
7.
What was the answer?
0.045.
Okay, got it. 1.045. That is so what I got, guys.
Great
Super
job.
easy. Once you actually look at what they're trying to
And then you
add.
see the probability for that one, right?
What was the probability?
For 7?
Score 160. We'll score above 160.
So we got 7 wrong.
Yeah.
So you just need the apple, but apple, not the Applebee's.
I would love Applebee's. So, okay, 1.045 for the z-score. And we want what's greater. So 0.1480.
Oh, so we just.
So 1.48. 0.148. 0.148. So I don't need
And then 12.
2 dots. So we already fixed 12.
So
That's it?
Yep.
Okay, I'll go ahead and see how this does. Save those. Go submit.
Yeah. So this is a valuable lesson. Make sure I read the fine
Read the
print. So I
fine
did the right
print.
thing.
Okay, so we missed a couple still. So 12 is still wrong.
awesome.
And then 12 is still wrong. 5 is still wrong, so it must be the law of large numbers. Maybe. We're gonna have you submit it again just to make sure. And then 3 is wrong. So what did you do on 3? How did we do? How are we messing up on 3? Using the normal app find the combined area under the normal curve. That's what we did. That's what that is. Right? So if we put
To the right.
1, 3,
We're
8,
not looking at
5.
the middle. We want to the right and to the left.
Okay, so what was the number? 0.1.
Oh, it's 1.
This
Oh,
one.
it's 0.17.
358. What? That is so not what I put. Oh my heavens.
Okay.
Point. Wait.
No, I think of it for some reason. I think of it
Okay.
as a beat.
That's 1.75.
Down this way, right?
Oh my god. I'm just not gonna even. Okay.
All right.
Wait. What'd you do?
Weird way, like-
I know. I did the 68, 95.
Okay. Well, I guess we're gonna know
And
for
then we'll
sure.
know it's the law.
I'll know for sure.
Did you fix?
Yeah, because I'm the last guinea pig, so for sure.
Did you fix?
No, not yet.
For some reason,
Okay.
I've never.
Okay, so standard deviation.
Oh, she did it.
Yeah, I did.
We have 0.078.
0.7. Oh, fudge. Okay, that's my bad.
Oh,
I put the 0 in the wrong spot.
oops.
And we don't know.
Oh no.
All right, let's see what happens. Yep, I missed one, so yeah, it's
Good lord.
it's a lot of large numbers.
Oh my gosh. Okay.
Okay.
So don't move off of your page. And then. Son of a. Whose was that? Is that yours?
What?
No.
Something weird vibrated.
How
And
much,
it
how
scared
many
the
hours of
crap out
battery life does your MacBook have?
12 hours.
Does this thing last maybe like 4 or 5?
I need minimal battery.
Yeah.
All right.
Okay.
It's another good reason to invest. Okay.
It is. It is so worth it.
This it drives me nuts having to constantly bring my cord.
Yeah. My cousin does the same thing. But she's like, I got this computer for
Okay, we
free,
gotta be
so I'm
quick
not
though,
gonna
'cause my
complain.
battery's almost
Okay,
dead.
yeah.
Okay.
So question 3.
Okay, so 3 is 0.175. Yep. Okay, I got 20 minutes.
Okay. We got this.
Okay,
4
4 is
the
the
distribution of
speed,
this-
the second one.
Okay.
5 is
The
law
love
of
of
numbers.
Wow, guys, we're super
My
awesome.
process of elimination, man, we really have to make sure we
Get
get
those.
down
I know.
when it comes to test time. Okay, so
Okay.
6 is 1.045. 7 is 0.148.
0.148.
Okay, 8 is 2.338. Okay, 9 is 0.01. Okay, 10 is approximately normal.
I don't like this.
Okay, 11 is 3.5. Okay, 12 is 0.078.
Gosh, I even calculated that.
What was that again?
12, 0.078.
I'm so mad. I even calculated that one.
Okay, 13 is 0.005.
0.005.
Mm-hmm. 0.005. Okay, 14 is 0.995. The one I was really unsure of. Okay, 15 is 0.055. Okay, my turn.
Here you go.
I'm going. I'll phone to you. I'm driving on fumes here.
Okay. High five, guys. We did it. Okay. Wow. Okay, true.
Okay,
Then
give me a second. Give me a second.
that's all you're gonna get is a second.
Okay, what's 3?
3 is 0.175.
Okay, 4 is B.
Yep.
5.
5 is law of large numbers. I swear.
Okay, 6.
6 is 1.045.
1.05. Okay. 7.
0.148.
8.
And 2.338.
2.8.
And 9 is 0.01.
Okay.
And then 10 is approximately normal.
Okay.
11, 3.5.
Okay, 12.
0.078.
13.
0.005.
14.
0.995.
15.
0.055. Nailed it. Okay. Oh,
Everyone.
okay.